Bismillahirrahmanirrahim. This is video about the derivative of a function. First, we look at techniques of differentiation. Here is the derivative formula for constant, linear, and power function. Please remember all the formula. Now I will explain how to use the formula. First, if we have a constant function or number, for example, fx equal to 4, if we want to differentiate constant, we will get 0. Means if we differentiate f prime x, differentiate 4, we will get 0. If we differentiate any numbers, we can get 0. If y equal to 100, differentiate this one respect to x, dy over dx, we will get 0. If we have y equal to pi is equal to 3.142, is also a number, so differentiate function y with respect to x, dy over dx, also we get 0 because we differentiate a number. Now we have fx equal to 2x. We have variable x here. So if we want to differentiate function f prime x, we will get 2. Differentiate 2x, we will get 2. If we have y equal to 9x, differentiate function y with respect to x, dy over dx will be equal to 9. Alright, now we have function x to the power of 5. So to differentiate this one, dy over dx equal to, we bring the power to the front, this power bring to the front, and then power minus 1. So we get 5x, the power of power 5 minus 1, we get 4. Now we have fx equal to 3x the power of 4. So if we differentiate this one, f prime x will be equal to, we will bring the power 4 to the front, so we will multiply by 3. So 3 multiplied by 4 multiplied by x, the power of 4 minus 1. 4 minus 1 is 3. So we get this one is equal to 12x power 3. Now if we have y equal to square root x, to differentiate this function, we can change types of square root is equal to x to the power of 1 over 2. So now we can differentiate dy over dx equal to, we bring the power of 1 over 2 to the front, so we have 1 over 2 x the power of 1 over 2 minus 1. So this one we get 1 over 2 x the power of 1 over 2 minus 1 is negative 1 over 2. Or we can write as 1 over 2 x the power of 1 over 2. So this one is equal to 1 over 2 square root x. Next example, we have y equal to 1 over x. To differentiate this one, we need to change to x the power of negative 1. So dy over dx is equal to, we bring negative 1 to the front, and then multiply by x, the power of negative 1 minus 1 is negative 2. So this one we can write as negative 1 over x, the power of 2. Next example is more complicated. We have function x and we have a power of any function x. Alright, look at this example. We have fx equal to 2x plus 1 the power of 3. So if we want to differentiate this one, f prime x will be equal to, first we will bring the power to the front, power 3, and then multiply by 2x plus 1, the power of power minus 1. 3 minus 1 we get 2. And then multiply by, we will differentiate. D over dx means we differentiate function in the bracket. We will differentiate 2x plus 1. So now we get 3, 2x plus 1, the power of 2, multiply by, differentiate 2x plus 1. Differentiate 2x, we will get 2, differentiate 1 is 0. So simplify this one, we get 6, 2x plus 1, the power of 2. Alright, let's try next example. We have y equal to 4x squared plus 3x plus 1, the power of 5. So we want to differentiate function y respect to x, dy over dx is equal to. So we have a power for our function. So first we will bring the power 5 to the front, 5, and then multiply by 4x squared plus 3x plus 1, the power of 5 minus 1, we get 4. And then multiply by, we will differentiate. D over dx means we will differentiate function in the bracket. We differentiate 4x squared plus 3x plus 1. So we will get 5, 4x squared plus 3x plus 1, the power of 4, multiply by, then the differentiate 4x squared, we get 8x plus differentiate 3x, we get 3, differentiate 1 is 0. Alright, try next example. We have fx equal to square root of x squared plus 1. So for square root, we change to x squared plus 1, the power of 1 over 2. So differentiate f from x will be equal to, we bring power to the front, power is 1 over 2, multiply by x squared plus 1, the power of 1 over 2 minus 1 is negative 1 over 2, and then multiply by, differentiate function in the bracket, function x squared plus 1. So we get 1 over 2 x squared plus 1, the power of negative 1 over 2, multiply by, differentiate function x squared plus 1, differentiate x squared, we get 2x, differentiate 1 is 0. Then we can cancel 2. So we can write our answer as x over x squared plus 1, the power of 1 over 2. Or we can write as x over square root x squared plus 1. Next is derivative formula for natural log function or ln x. Remember this formula, if we differentiate ln x, we will get 1 over x. If we differentiate function ln fx, we will get 1 over fx and then multiply by their differentiation f prime x. If we have ln the power of n fx, and then we will bring n to the front, power n, bring to the front, multiply by ln the power of n minus 1, and then multiply by differentiation of the function ln fx. Look at this example. We have fx equal to ln x. So if we differentiate this function f prime x, we will get 1 over x. Remember, differentiate ln x, we will get 1 over x. But if we have function y equal to ln 2x, so to differentiate function y with respect to x, dy over dx will be equal to, so remember formula, ln x, if we differentiate ln x, we will get 1 over x. So differentiate ln 2x, we will get 1 over 2x. But for this function, we have function 2x in the bracket, so we need to multiply by differentiation of the function in the bracket. Means we will differentiate function 2x. So we get 1 over 2x, and then multiply by differentiate 2x, we get 2. And then simplify this one, we will get 1 over x. Now, if we have function fx equal to ln 5x squared minus 3, so we want to differentiate this function, f prime x will be equal to, so differentiate ln, we will get 1 over function in the bracket, 5x squared minus 3. And then multiply by, we will differentiate function in the bracket. Differentiate function 5x squared minus 3. So we will get 1 over 5x squared minus 3 multiply by differentiate 5x squared minus 3. Differentiate 5x squared, we get 10x, differentiate 3, 0. So we get our answer is 10x divided by 5x squared minus 3. Alright, now we have function ln the power of 3. The function is 4x plus 2. Please take note that this function we also can write as ln 4x plus 2 the power of 3. So the power of 3 is referred to the power of ln. So to differentiate this function, dy over dx will be equal to, so first we will bring the power 3 to the front. So we have 3 ln 4x plus 2 the power of, and then power minus 1. So 3 minus 1 is 2. So we have the power of 2. And then multiply by, we will differentiate function ln 4x plus 2. So we get 3 multiplied by ln 4x plus 2 the power of 2 multiply by, and then we differentiate ln 4x plus 2. Differentiate ln, we will get 1 over 4x plus 2. And then we will differentiate function in the bracket. Differentiate 4x plus 2, we get 4. Then simplify this function, we can multiply 3 multiplied by 4, we have 12 ln 4x plus 2 the power of 2 divided by 4x plus 2. Next is derivative formula for exponential function. If we have function exponent x, if we differentiate function exponent x, we will get exponent x. If we differentiate function exponent the power of fx, then we will get exponent fx, and then multiply by differentiate function fx. Look at this example. If we have fx equal to ex, differentiate function ex, f prime x will be equal to, we get the same function, we get ex. But if we have fx equal to e to x, f prime x will be equal to, first we write exponent 2x, and then we need to multiply by differentiate function 2x. So here we get e 2x multiplied by differentiate 2x, we get 2, or we can write as 2e 2x. Let's try next example. We have y equal to e the power of 3x minus 1. So differentiate function y respect to x, dy over dx equal to, so first differentiate exponent, we write the function exponent 3x minus 1, and then multiply by, we need to differentiate function 3x minus 1. So here we have e 3x minus 1 multiply by differentiate 3x minus 1, we get 3. So the answer is 3e 3x minus 1. Alright, let's try this example. Y equal to 4 over e 6x. So to differentiate this one, we need to change to the polynomial function. So we can write as 4 exponent the power of negative 6x. So differentiate function y respect to x, dy over dx equal to 4 multiplied by exponent negative 6x, and then multiply by differentiate function negative 6x. So we get 4e negative 6x multiply by differentiate negative 6x, we get negative 6. So now we get negative 24 exponent negative 6x, or we can write as negative 24 over e 6x. This is the derivative formula for trigonometric functions. Please remember all the formula. Look at this example. We have y equal to 4x. So we want to differentiate function sine 4x. So dy over dx will be equal to, so first we will differentiate sine, we will get cos. And then we write their function in the bracket. And then we need to multiply by function in the bracket. Differentiate 4x. So we will get cos 4x multiply by differentiate 4x, we get 4. Or we can write as 4 cos 4x. Next example, we have fx equal to cos x to the power of 4 plus 3. So to differentiate this one, f prime x equal to, so first we differentiate function cos. Differentiate cos, we will get negative sine. Negative sine, and then write the function in the bracket. Their function is x to the power of 4 plus 3. And then multiply by differentiate function x to the power of 4 plus 3. We get 4x to the power of 3. Or we can write as negative 4x to the power of 3 sine x to the power of 4 plus 3. Alright, let's try next example. Fx equal to tangent ln x. So f prime x equal to, so first we differentiate tangent, we will get secant square. Secant square, and then we write their function ln x, and then multiply by, we differentiate function ln x. Remember, differentiate ln x, we will get 1 over x. Or we can write secant square ln x over x. Alright, let's try this example. Y equal to 3 second 5x square. Differentiate dy over dx equal to 3 is constant multiplied by second, so we just write the constant 3 and then we differentiate function second. So by using formula differentiate second, we will get second tangent. So we get second, write their function 5x square and then tangent 5x square. And then multiply by, we differentiate function 5x square. Differentiate 5x square, we get 10x. Then the answer is 30x multiplied by second 5x square tangent 5x square. Next example, y equal to cotangent exponent 2x. So differentiate dy over dx equal to, first we differentiate cotangent. By using formula we will get negative cosecant square. So we get negative cosecant square and then we write the function is exponent 2x and then multiply by, we differentiate function exponent 2x. So we get exponent 2x multiply by differentiate 2x, we get 2. So we get the answer is negative 2e 2x multiply by cosecant square exponent 2x. Next example, we have y equal to 2 cosecant x. So differentiate dy over dx will be equal to, 2 is constant, so we just write the constant and then multiply by differentiate function cosecant. Differentiate cosecant, we will get negative cosecant cotangent. So we get negative cosecant function is x multiplied by cotangent function x. And then differentiate x, we get 1. Next example, we have sine the power of 2, 3x plus 1. So sine the power of 2, we can also write as sine 3x plus 1 the power of 2. Means the power of 2 is belongs to sine. So to differentiate function trigonometric that has a power, f prime x will be equal to, so first we solve for their power. Power 2 will bring to the front 2 and then multiply by sine 3x plus 1 the power of, and then power minus 1, so 2 minus 1 is 1. And then multiply by, we will differentiate function sine 3x plus 1. So here we will get 2 sine 3x plus 1 multiply by, then differentiate sine, we get cos, and then write their function is 3x plus 1 multiply by, then we need to differentiate function in the bracket. Differentiate 3x plus 1, we get 3. So we get the answer is 6 multiply by sine 3x plus 1 multiply by cos 3x plus 1. Next example, we have y equal to cos the power of 3 e for x. So this function we can write as cos e for x bracket the power of 3, means the power of 3 is belong to cos. So to find dy over dx, first we bring the power to the front. The power is 3, so we have 3 and then multiply by, we write the function cos e for x, and then power minus 1, power 3 minus 1, we have 2, and then multiply by, we will differentiate function cos e for x. So we get 3 cos e for x, the power of 2, multiply by, differentiate function cos e for x. First we differentiate cos, we get negative sign, and then write their function is e for x, and then multiply by, differentiate function exponent for x. Differentiate e for x, we get 4e for x. Then simplify our answer, we get negative 3 multiplied by 4, negative 12, exponent for x, cos e for x, the power of 2, multiplied by sine e for x.